Today we're going to start reviewing for the semester 2 final, topic 5. In the beginning of topic 5, focused on points of concurrency, so I put this table in here to remind you. If you are asked to do something with the circumcenter, then that goes with perpendicular bisectors. As you can see from this first picture, each of these segments bisected a side of the triangle and is perpendicular to that side of the triangle. The part of the information that you may be asked to use is that it's equidistant from the three vertices, meaning that this distance here to the vertex is equal to this distance to this vertex, which is equal to the distance to this vertex. Because the circle, every point on the circle is equidistant from the center, and each of the vertices goes through the circle. Which means that if you were asked to write an equation, these three segments are all congruent. And the next one they might ask you about is the incenter. Okay, that is made by angle bisectors. And the significance of that is that it's equidistant from the three sides, meaning that this circle here, this point is equidistant to this point, which is equidistant to this point, because all of the points on the circle are equidistant from the center. So, and this circle touches the sides of the triangle, not the vertices. So the one above, the vertices are touched. The one below, it's the sides that are touched. So when you guys are designing your notes for the final, this is information that you're going to need. Okay. So the other 2 points, you've centroid and orthocenter, you probably won't need to do anything with them because they don't really have special properties that you can use to write equations. Okay, so for this guy here, they're telling us that it's perpendicular bisectors. They're telling us it's the circumcenter. Okay, that means that if I was going to draw, I could draw a circle and it would touch all of the vertices, meaning this segment is congruent to this segment, is congruent to this segment. So since FC is 25, so is AG. This is also 25, and this is also 25. Since these are all perpendicular bisectors, that means that these are all hitting at right angles, which means that we can also use the Pythagorean theorem to find some other sides. Okay, and since they're perpendicular bisectors, all of these, the sides of the triangle are bisected. So this is 15. Both of these are 24. Both of these are 20. Okay, so CF is this guy here. That's going to be 24. CE, I already have labeled as 15. That's this guy here. BD, I already have labeled as 20. AB is both halves together, which makes it 40. And AC is both halves together, which makes it 48. And the measure of angle ADG is 90 degrees because they're perpendicular bisectors. So the only one that we need to write an equation for is if BG is 2x minus 15 fine x. Well, I already have identified that BG is 25. So 2x minus 15 equals 25. Add 15 to both sides, meaning that 2x equals 40, which means that x equals 20. Okay, this next one is about the incenter. Okay, that is made by angle bisectors, which means that if this is 31 degrees, then this is also 31 degrees. If this is 27 degrees, then this is also 27 degrees. Okay. So what is the length of JP? Okay. So this is 20, this is 12, and this is a right triangle. So we can use the Pythagorean theorem to find the length of JP. So 12 squared plus JP squared equals 20 squared. So 144 plus JP squared equals 400. Subtract 144 from both sides, and we get that JP squared equals 256. Take the square root of both sides, and we get that JP equals 16. So if JP is 16, and this is an end center, which means that all of the distances to the sides are the same, that means that LP is 16 and KP is 16. They're all the same length. Okay, the next part of chapter 5, sorry, that we're going to need is the angle bisector theorem for an isosceles triangle. Basically, it tells us that if we know any one of these pieces of information, we know everything else. If we know that this angle is bisected and it's an isosceles triangle, then we also know that the opposite side is bisected, and we also know that it's bisected at a right angle. Also, because it's an isosceles triangle, if we know these two sides are congruent, we also know that the base angles are also congruent. So there's tons of information that you can gather just by knowing that it's an isosceles triangle and that that vertex angle is bisected. Okay, so because this is an isosceles triangle indicated here, and the angle is bisected indicated here, that means that 12 equals x plus 23. Subtract 23 from both sides, and we get that x equals negative 11. Yep. Okay. And because the opposite side is bisected and it's perpendicular, okay, we know that this is an isosceles triangle because we know that this point is equidistant from T, and it's equidistant from V, which means that 3x plus 9 equals 7x minus 17. Cancel out the smallest x first, so subtract 3x from both sides. And then we're going to add 17 to the other side, which gets us 26 equals 4x. And then divide by 4. It does not go in evenly, so we can leave our answer as a fraction. You can leave it as 13 halves, or if you want, you can make it 6.5. Either one is it correct. Okay, the last tidbit that we're going to need for this review is the triangle inequality theorem, and it tells us that any two sides of the triangle have to be bigger. The sum of any two sides has to be bigger than the third side. But there's a corollary to that, which tells you that you should also be able to subtract them and have that side be bigger than them. So the purpose of this absolute value here is to make sure that you subtract them in such a way so that you get a positive number. So if one side is 5 and the other side is 3, don't do 3 minus 5 to get negative 2. You're going to do 5 minus 3 to get 2. So in other words, each side of the triangle is bigger than the difference of the other two sides and smaller than the sum of the other two sides. Okay, so we can subtract them on the left, we can add them on the right, and my third side is going to be right smack in the middle of those two answers. So the possible side lengths for this third side are, I can subtract the numbers, or I can add the numbers. So 16 minus 11 means that x has to either be bigger than 5, or it has to be smaller, it has to be smaller than 27. Oh, that's not right. x has to be between 5 and 27. So it's bigger than the difference, it's smaller than the sum. So for this next one, when they ask you if these triangles, if this could be a triangle, well, the idea is every side in between the difference and the sum of the other two. So could I do 28, is 28 minus 16, put 39 in the middle, and then 28 plus 16. Is this a true statement? Right? So 39 is definitely bigger than 28 minus 16, and it is definitely smaller than 28 plus 16. So that works. Okay, what if I put 16 in the middle? Okay, so 39 minus 28, those are the other two sides, and then 39 plus 28. Is this still a true statement? Is 39 minus 28 smaller than 16? Yes. Is 39 plus 28 bigger than 16? Yes. Okay, and then put the last number in the middle. Put 28 in the middle. Does it work? So I'm going to add 16 and 39 on the right. I'm going to subtract 16 and 39 on the left. So 39 minus 16, is that smaller than 28? Yes, it is. Is 16 plus 39 bigger than 28? Yes, it is. So the answer is yes. A triangle could have these side lengths.